Hello guys, today we're going to be solving a fun little geometry problem where we have an isosceles triangle ABC with its base angles being 30 and a median to one of its legs being 7. And using this we have to find the area of the whole triangle. So how would one possibly do that? I mean, the first thought is dropping another median and altitude, same thing, from B over to base AC, and we would have some special right triangles. There would be no ratios of intersecting medians. You know, that's one way to approach it. But there's also another way to approach it by recalling two formulas, two equations more so. One equation that relates medians in a triangle, what we have, and one that finds the area of a triangle using one of the angles. So let me write those down. For medians, we know that 4m squared plus c squared equals 2a squared plus 2b squared, where m is the median, c is the side that it falls on, and a and b are the sides of the triangle. Very useful formula, actually. Please remember it for the future. It can be used many places. And the second formula, which finds the area of a triangle, which states that area is a times b times sine of c over 2. So that means it is the sides multiplied times the angle between them over 2. So in this case, the area of ABC actually is going to be AB times BC times sine of 30 degrees over 2. That doesn't really help us. What we'll have to do is make some system of equations with two unknowns, and then find those two unknowns to later help us. So let's start by saying that AC is y, and AB, which is the same as BC, is x. And the plan is going to be to find this x and then just plug it into our formula for area, right? If we know AB, then we can use this formula to say x times times the sine of this angle B over 2 is going to be the area of the triangle. So that's our plan. So let's try to use these formulas to relate some numbers we have. So first one for medians. 4 times 7 squared, we have the length of the median, it's 7, equals to 2bc squared, so 2x squared plus, miswrote, 4m squared plus x squared equals to 2x squared plus 2y squared, right? Plus this side equals the 2 times x squared of this side. Okay, good, let's clean this up a bit. This means that 4 times 49 equals x squared plus 2y squared, right? So we're removing x from this side, all right? Which means that 196 is x squared plus 2y squared. Very nice. But then, the tricky part is figuring out how to use this area formula. We can't just apply it to our whole triangle ABC, because that wouldn't give us a system. We would say something like x times y times sine of 30 over 2 equals the area of ABC. But remember, ABC is also an unknown. It wouldn't be possible to solve such a system. So we would have to remember one last thing about medians. We know that a median splits the area of a triangle into two triangles of equal area. That means the area of triangle ABD is equal to the area of triangle ABC, right? And this is very nice because we can use our sides of a triangle to relate the two triangle areas. So let's do just that. Let's say that the area of triangle ABC, which is going to be y times x over 2 times the sine of 30 degrees. Remember, this angle is 30 degrees, and that this side DC is x over 2, because we're given this is a median, right? All of that over 2 equals the area of triangle ABD. Alright, triangle ABD seems like x right here, times another x over 2, times the sine of this angle B, which we can quickly deduce is 120 degrees. Okay, so by sum of angles in a triangle, by the way. It's going to be x times x over 2 times sine of 120 degrees over 2. Very nice. So we now have our two equations that we can use, and we can find our unknown x, and then we can plug it in to find the final area. So let's quickly solve these equations. First, this implies we can completely get rid of this 2, so we can say that yx over 2 times sine of 30 degrees is 1/2 equals x squared over 2. Sine of 120 degrees is √3 over 2. Remember that. Okay, seems like we have yx over 4 equals x squared √3 over 4. So we can again get rid of this denominator. This implies that then yx is equal to x squared √3, or then we can find y, which is equal to x √3, right? So we divide it by x squared divided by x is just x. Very nice, we have our y. And now we can plug it in back into our first median equation, and then we'll have a simple equation with one unknown. And it's exactly what we need, x. Once we find x, we can find the area. So let's do that too. 196 equal to x squared plus 2 times y, which is x √3 squared. So that means 196 is equal to x squared plus 2 times x squared times 3, okay? Times 3. So 196 equals 1x squared plus 6x squared, right? 2 times 3, 6. 6x squared. So we can conclude that 196 is equal to 7x squared. Or that x squared is equal to 28. So we have a last found x, which is root of 28. Perfect. Let's plug it in into our final equation, AB times BC times sine of 120 over 2, and that will be the area of the whole triangle. Okay? We have root 28 times root 20. Oh, I forgot. Yeah, it's the area of the triangle. Times sine of 120 over 2. So that is equal to 28 root 3 over 2 over 2, which is equal to 28 root 3 over 4. And finally, that's 7 root 4. And that is the area of triangle ABC. We have solved it. That's the problem. It's very interesting that the area of this isosceles triangle is √3 times the length of its median. Try to prove it for a general case for such an isosceles triangle. And that's it. Thanks for watching.